In the previous chapter, we used dependency constraints to influence the version of a transitive dependency. In this chapter, we will go over how you can define rich version constraints for dependencies. In addition to using dynamic versions and version ranges, Gradle allows you to more granularly control dependency version selection through rich versions. Rich versions allow you to define the strictness for a dependency version using specific keywords. Rich versions can be used for declared dependencies or for constraints on transitive dependencies. In the documentation, you can search for declaring versions and click on the first result. Here, you can see an example of rich versions being used for a dependency declaration. A range of versions is specified using the strictly keyword. There are 4 options available for declaring rich versions. The prefer option can be used to indicate that if multiple suitable versions are available, then Gradle should pick the version specified with this option. This is the least strict of all 4 options. You can use require to specify the minimum version of the dependency that Gradle should select. When using the strictly option, the strongest option, Gradle must select a version from the ones specified. Finally, if there are versions you definitely do not want Gradle to fetch, you can specify those versions with the reject option. You can use multiple options together. In this example, Gradle will select any version between 1.7 and 1.8, excluding 1.8 of SL4J. If version 1.7.25 is an option, Gradle will prefer it. And in this example, Gradle will select any version higher than 4.2.9.release of Spring Core, except for version 4.3.16.release. Let's go back to our calculator example. We will improve the constraints on OKIO, which currently use version ranges, to use rich versions instead. If we go to the calculator build file, we can update the constraints block to explicitly reject the buggy version of OKIO, version 3.16.2. We also need to let Gradle know which range of versions is acceptable. We don't want to reject future versions of OKIO, such as 3.16.7, which the previous version range will omit. For this, we use a dynamic version in a strictly block. Now we run the dependencies task again. We can see it picks the highest version available and rejects 3.16.2. When multiple constraints are placed on a single library, Gradle attempts to find a version that satisfies all requirements. If these constraints are mutually exclusive, meaning there is no version that overlaps, the build will fail. For example, the math library now adds a strict constraint on OKHTTP version 5.3.0. And the calculator app now adds a require constraint on OKHTTP version 5.3.2. As a result, when we run the dependencies task, we see that the build fails because there is no overlap between the strict 5.3.0 in math and the require 5.3.2 in calc. This is a deliberate safety feature in Gradle. Rather than silently picking a best guess version that might satisfy one requirement while breaking another, Gradle halts the build to prevent binary incompatibility or runtime crashes. To resolve the failure, you could update the calc constraint to a strictly 5.3.2 instead of a require to force a specific version. A strictly closer to the root of the build takes precedence over any strictly constraints coming from your transitive dependencies. If you are using the version catalog to manage dependencies, rich versions are supported there too. The format is similar. Here is an example of what it looks like. You can also refer to the version catalog documentation for more examples.